friends. Today I will discuss problem from Striver's TP list. The problem is partition equal subset sum. So yeah, let's open the Leetcode problem statement and see. So problem is we have given a non-empty array nums which is containing only positive integers. We have to find that. An array can be partitioned into two subsets such that the sum of each subset is equal. So yeah, so we have given array like nums equal to 1, 5, 11, and 5. There is 4 elements. So we have to find that can we partition this array into two subsets such that the sum of each subset is equal. So if it is true, then we have to return true, otherwise we have to return false. Let's discuss how we can do using dynamic programming. uh, yeah, so let's check this example. So here we have given 1, 5, 11, 5. So we have to calculate the subset. So it is sure that in array we have two subsets and the sum of each subset is equal. So let's assume the sum of an array is odd. Can we partition this array into two subsets? Of course not. Uh, because if the sum is 13, if the sum is 13, then how we can partition into two subsets? Because when we divide 2, it's not divisible by 2, so we cannot partition into two subsets. But if the sum of the whole array is even, the sum of whole array is even, then we can partition into two subsets which have same sum. Let's assume an array 1, 6, 7, 1. So here the sum is 15. Sum is 15. Can we partition this array into two subsets? No, because the sum is 15, so we have to just return the false. We cannot partition it into two subsets. But here in upper array, we have 1, 5, 11, and 5. So we can partition it into two subsets. So let's sum this. So it becomes 22. 22 more divided by 2 is 11. So yeah, so each subset has some 11. This subset has some 11. So we find in array that is there any subset possible? Is there any subset possible which has some 11? Which has some 11? If yes, then it is sure that the sum of the other subset is also 11 because the total because the because the total sum is 22. So if one subset in the array have some 11, then it is sure that the other subset have the same sum. So it is similar to the previous problem as I discussed in the previous video. So I put that video link in the description. Uh, so let's see. So just we have to just uh, we have to just do summation of all elements, and if this is odd, we have to just return false. Return false. We cannot partition it into two subsets. And if it is even, then we can check. Then we can check that is it possible that a subset has some uh, equal to total sum upon 2. So total sum upon 2. If one subset have this sum, one subset, then we can return yes, it is possible that we can partition the array into two subsets. So we are doing here using our dynamic programming recursive method, which is the memoization method. So uh, so yeah, so let's see the one second. So yeah, let's see the solution how I did. So yeah, so we have given this function in which we have given an array. So here I defined a dp, uh, and this is the total sum possible, which is one element x maybe 100, and total number of elements is 200. So maximum summation may be 200 into 100, which is 20,000. So I taken this for summation, and this is the index of the array. So here I did the summation of all the elements of the array, and if this is odd, so I return false here, and if this is even, then I checked here that is it possible that one subset has sum equal to sum upon 2. So if it is true, then yeah, so if it is true, then we have returned here carry. So yeah, as we discussed this in the previous problem, how I calculated for the particular sum, that is it possible to it is possible that a subset with sum is equal to the target sum. So here I passed the subset sum, and this is the carry. If current sum is equal to the subset sum, in current sum we are storing the sum of the elements, and if it is true, then we have to store true in carry, and return from here, and this is the edge case, and here we are storing dp1. So if it is not equal to -1, that is we already visited that sum and that index, then we have to return here, and otherwise we have to store 1. And if current sum is greater than subset sum, then we have to return here. And similarly, as we discussed in the previous lecture, here we are in one time we are including the element, and in the second time we are excluding the element, and checking that if we include that element and form a subset, that it is possible to make a sum equal to subset sum, or if we exclude that element and form a subset, then it is possible. Is it possible to make a subset that sum is equal to subset sum? So yeah, if it is true, then we have to return true here. Otherwise, we have to return false here. So globally, we store the value as false. So yeah, that's, thank you.